Okay, before we start with another example, I just want to go back to the previous example and reiterate an important point. Okay, so if you look at this part of the problem, right here, we were being asked for the probability that x is greater than 11. Okay, so the variable of interest is x. We know that x is normally distributed with the mean of 9, right, and a standard deviation of 1. So when you standardize this problem, you're supposed to use 9 for the mean and 1 for the standard deviation. Okay. When we got to this part of the problem, we were asked for the probability that x bar is greater than 11, right? So the variable of interest here is x bar. We know that x bar is also normally distributed with the mean of 9 and a standard deviation of 0.25, right? Remember that this is the standard deviation of all the sample means. Another name for it is the standard error of the mean, right? So I can say the standard deviation of all the sample means or the standard error of the mean is the same thing, right? Anyhow, the variable of interest here is normally distributed with the mean of 9 and a standard deviation of 0.25. So when you standardize this problem, you're supposed to use 9 for the mean and 0.25 for the standard deviation, right? And because of the difference in the standard deviation, although these two problems look similar, they are not the same problem, right? In one problem, we use 1 for the standard deviation. In the other problem, we use 0.25, and that led us to very different answers across the two problems. Okay, so you want to be careful when you do this type of questions. Okay. Okay. So now let's move on to our next example. Suppose that the number of small businesses per city has a mean of 12,485 and a standard deviation of 21,973. Okay. Let's say we're interested in a sample of size 10. Okay. Let's find the probability that the sample average or the sample mean is greater than 17,000. Okay. Okay. So let's call this variable x, right? So let x be the number of small businesses per city. Okay. Then we know that x has a mean of 12,485 and a standard deviation of 21,973. Okay. Now we have a sample of size 10. Okay? Now if you translate the question from English into probability term, essentially what we want to find is we want to find the probability that x bar is greater than 17,000, right? So the probability that the sample mean, so the sample mean is x bar. Right, so we're being asked about the sample mean, that's why we have x bar right here, okay? So how do we do this? Because we're being asked about x bar, what we want to do first is we want to know how x bar is distributed, right? In other words, we want to know the sampling distribution of the sample mean x bar. Okay. So first off, the expected value of the sample means, right, which is the mean of all the means, is equal to the population mean, right? So the mean of the underlying variable, which is 12,485, okay? Second, the standard error, sigma x bar, is equal to sigma x divided by root n. So this is going to be equal to 21,973 divided by the square root of 10. Okay, so let's now look at the distribution shape. So let's first ask the question, is x normal? Right? If x is normal, then x bar must be normal, right? No question asked. If x is not normal, then what do? Then we will have to look at the sample size n, right? Okay. If n is greater than or equal to 30, then x bar will be normal. Okay. Okay. So now in this problem, right, we were given the mean and we were given the standard deviation, but we were not given the distribution of the variable x. And so, is x normal? The answer would be no. Okay, so now we look at the sample size. We have a sample size of 10 observations. Because the sample size is less than 30 observations, our conclusion is that we don't know the distribution we don't know the distribution of x bar, and because we don't know the distribution of x bar, we definitely cannot use a z-table, right? We cannot use a standard normal table, so we cannot find the probability that x bar is greater than 17,000. Okay. Okay. So now let's ask a follow-up question. Okay. Let's ask which assumption do we need to make for x bar to be normal? So let's go back here, right? We know that our sample size is 10, which is less than 30, right? Because the sample size is less than 30, if x is not normally distributed, then there's no way x bar will be normally distributed. Okay? So because n equals 10 less than 30, if x is not normal, then x bar will not be normal. Okay? So now what is the assumption that we need to make? That means that we need to assume x is normal. Okay? Think about it, right? If we assume that x is normal, then we're in this part of the tree, right? If x is normal, then x bar is definitely normal regardless of the sample size. Okay? So as long as x is normal, even if we have a sample size of less than 10, then x bar is going to be normal always. Okay? So the assumption that we need to make is that we need to make the assumption that x is normally distributed. Okay? This is a very important point, right? If you watch the video and you don't understand this part, make sure to make an appointment to see me. We can walk. I can walk you through the logic. Okay. Okay. So now let's do a follow-up question. Another follow-up question. Let's say a sample of size 36 is randomly selected. Okay. Let's find the probability that the sample average is greater than 17,000. Okay. Again, if you translate this question into probability terms, this is the probability that x bar is greater than 17,000. Okay, so we're being asked for the probability that x bar is greater than 17,000. Okay. So this means that we need to know the sampling distribution of the mean of size 36. Okay. So first off, the expected value of all the mean is equal to the mean of all the means, which is equal to the mean of the underlying variable, which is 12,485. Now the standard error, sigma x bar is equal to sigma x divided by the square root of the sample size, which is equal to 21,973 divided by the square root of the sample size, right? In this case, we have a sample size of 36, so we divide it by the square root of 36. This gives us 21,973 divided by 6, which is 3,662.17. Okay? So now the last thing we want to know is the distribution shape. Okay. So now is x normal? The answer is we don't know, right? In the original problem, we weren't told whether x is normal or not. Okay. So we want to look at the sample size. If n is greater than or equal to 30, then x bar will be normal. Okay. Here we have a sample size of 36, which is greater than 30, and so x bar is normally distributed. Okay. So now we want to find the probability that x bar is greater than 17,000. Okay. Know that x bar is normal with a mean of 12,485 and a standard deviation of 3,662.17. That means that x bar is not standard normal. Okay, so if x bar is not standard normal, you want to go ahead and standardize it, right? So we standardize by subtracting the mean divided by the standard deviation. We do that for x bar, and then we also do it for 17,000. Okay. Okay, so you know the drill. This is the probability that z is greater than 17,000 minus 12,485 divided by 3,662.17. Okay, which is the probability that z is greater than 1.23. Now, in order to use a table, we need to flip the inequality sign. So this is equal to 1 minus the probability that z is less than or equal to 1.23. Okay, so now you just need to go to the table, look for 1.23 in the margin, and get the probability. So we go to row 1.2, look under column 0.03, and that gives us a probability of 0.9807. So if you do the math, this gives us 0.1093 as the answer. Okay.